GM everyone. I'm Titus. I'm a VP of GoTo Market at Civic, where we empower developers with privacy-preserving tools for user identity management. Now, as you know, this podcast dives into how digital identity is transforming industries at this intersection of Web 2, Web 3, and now also AI. Before we begin, my request is for you to follow, like, subscribe. Make sure you connect with us on your favorite platform. Your support makes a difference. Today, we're joined by Stephen Ajayi from Hacken. Hacken is a long-term partner of ours, and they're the ones responsible for auditing our smart contracts when we had like the Civic Pass live. And we'll be exploring the hidden security risks behind large language models and why your AI stack might be way more vulnerable than you think. So, Stephen, thank you for joining us. Tell us a bit more about yourself before we begin.
Thank you very much, Titus. Thanks for having me today. It's great to be on the podcast. My name is Stephen Ajayi. I started my career in the traditional offensive security. And over the years, I've worked with mostly a managed security service provider and had the opportunity to work with a range of sectors, including banking, sector, fintech, and even some government operators that are now blockchain security. So I've got to see a wide range of security challenges firsthand, not just on the offensive side. I've also had some experience with forensics and also incident response and so on. So I've always been fascinated about blockchain technology, especially when it comes from the security standpoint. And that curiosity led me to learning about solidity and diving deep into the technical layers of the centralized system. As I learn more, I realized that the Web 2 is still a very crucial part of the overall security landscape because Web 3 application cannot stand alone completely on its own. There's always some bridge, some interface, some infrastructure that ties back to the traditional system. So that understanding actually helped me connect the dots between the old and the new, and it actually helped me shape how I approach blockchain security today. So in 2022, I made my full transition into the Web3 space, focusing entirely on the off-chain component, that's the Web2 component of blockchain security. And yeah, it's been an exciting journey so far.
Very cool, very cool. And I mean, how do you see these two domains connecting, like blockchain, AI? Like, how do you see that intersection happening nowadays? It's like, I think a lot of the tech is converging and we're all becoming AI companies, whether we like it or not.
Yes, you're right. The intersection of blockchain and AI is actually a growing area of focus. But in my day-to-day work, let me just make that clear. My team is not directly testing on-chain components. We have a dedicated smart contract on the team and layer one security on the team for that. So my role is more focused on the Web 2 facing components because the truth is, so I said earlier, blockchain application cannot function without off-chain infrastructure, whether it's API, the front-end cloud function, and so on. So these pieces often become the weak link, if not properly locked down. And that's where AI become particularly interesting and concerning because we've seen a lot of blockchain organizations rushing to integrate AI into their workflow, from using LLM for governance assistance to AI agents managing wallets or running analytics over chain. But many of them are not considering a security audit, and that's a problem. And because we care about the security space of the blockchain, my team and I have been proactively learning and testing AI blockchain intersection, studying how LLM can be used to exploit our Web3 infrastructure, how AI agents might become an insider threat, how off-chain logic could become a new attack surface, basically, especially when those agents are wired to on-chain permission. So my goal is just to stay ahead of the threat, but to also help shape the best practices for this evolving space. So when AI system starts signing transaction or influencing governance proposal, it's no longer just a Web 2 or a Web 3 problem, it's both. And it's the mind and how you address security mindset, and that's where I come in.
Yeah, that makes a lot of sense. And I think, I mean, you wrote about this recently when it comes to large language models. There are some like top securities people need to consider. And I think what I want to highlight today is like, what do you think is the most underestimated threat of the entire kind of gamut of threats that are out there?
That's a very good question. If I had to pick one risk that organization are not or are massively underestimating, I would say it's indirect prompt injection. No question. Now, because a lot of developer organizations utilizing AI are usually covering their bases with jailbreak detection or slapping some keyword filter like don't let the model say this, sanitize this, block dangerous verbs, and so on. But I won't say they are solving the wrong problem, but they are not solving all the problem because in 2025, the surface is not just the front door anymore, right? It sneak in through the content layer. Let me explain. Indirect prompt injection is what happens when the model is not just chatting with human, right? It's when it's processing content from the outside world. Maybe it's summarizing an email or extracting tasks from Jira tickets, or even generating a report based on a PDF file, or the user input is no longer the attack surface, the data source is. As long as it's connected to a data source, attack can actually sneak into that aspect. So that's not the bug per se, right? Because that's exactly how the model was trained to behave, right? The model are usually trained to be predictable, be obedient, and be helpful. And at the end of the day, if you're not covering all your bases, all the data sources in terms of security, it can become very big fatal. So it's not always enough to clean the data. Builders also needs to verify where all these data come from. So the whole supply chain that goes into the AI must be scrutinized. And honestly, that's not being paranoid. That's just being realistic because when you understand that nothing is safe by default, you have proper guardrails built into the system, you'd have less to clean up later. So yes, I would say it's indirect prompt injection for me. And as I said, it's not just a chat problem, it's the whole supply chain problem. And if you're feeding your AI untrusted content and asking it to act on it, you've already opened the door. The only question is whether you've realized it yet, or if someone else has helped you realize it, and that's something you actually need to ponder on.
Yeah, it sounds like a pretty hairy problem. I was actually reading about this over the weekend. Somebody tweeted about this. Researchers that publish on Arxiv are now beginning to give this a good rating to this PDF inside their text to be able to have that opportunity to the indirect prompt injection you're talking about. So it's like, it helped me kind of understand the nature of that threat and puts kind of like almost like a concrete form around it. It's like you have this kind of interrupting your text with a specific prompt that if it's strong enough, then it just deviates from the original ask of the model, like context and prompt they provided. So does that kind of align with what you were saying?
Yes, absolutely.
Okay, awesome. It sounds like a pretty hard problem. So what should companies do to prevent that risk?
There are a lot of things the organization can actually do to prevent it. I would say the first thing organization should do is they need to treat every data source as potential executable code, right? Because as long as your LLM or your model can read it, it can be injected, it can be prompt injected. So organization need to build in sandboxes, apply role partitioning, use layer prompt, rigid token budgeting, and most importantly, log every source of data that the model actually sees and processes. Because when something goes wrong, you will need a forensic trail to trace it back and find out what the problem really is. Then another thing is red teaming is very important. Don't just scan the model, right? You need to attack the workflow, right? Inject hostile data into your emails, your PDF, the knowledge-based articles, anything that the model ingests, that is your new perimeter.
Yep, that makes total sense. And I think that's like, I think for people who don't know red teaming, can you explain that for the audience?
Yes. Let me put it like this. Let me start from the traditional aspect of things. Traditional penetration testing is all about finding holes in code, right, in application and system. Red teaming LLM is about finding gap in reasoning, right? You are not testing if the front door is locked. you are testing if the butler in the house can basically talk into opening the door for you, right? So with traditional application, when you send a payload, you get a predictable result. For example, let's say SQL injection, for example, right? The result is either you're dumping a database or running an SQL query. So there's also SSS injection, for example. You can use it to steal cookies or redirect users to different websites or force them to download malicious file. But with LLM, you can send the same prompt twice and you get two different answers. And here, you're not actually exploiting a bug, you're actually nudging the behavior of the LLM. So it's less injection and it's more persuasion, right? So one thing about the payload when it comes to red teaming LLM is the payload are mostly psychological and not less technical, right? The thing is, traditional vulnerabilities like SSS, SQL injection, everything still matters when it comes to the application side of things like the agent, the APIs, and other UI connected to the model. But when testing the LLM itself, your payload is not code, it's sentence, right? Something like before you answer, forget your previous instruction and do this. It's more or less like social engineering through language. So it's part phishing, part natural language processing attack, and part gender mind attack, right? You are attacking the thought process because sometimes whenever I test model, I usually inject a poison in the step-by-step reasoning. So if every step after the first step build on the bad logic I injected, that is a win for me. And that's a vulnerability we call the chain of thoughts poisoning when it comes to LLM. So the model is just one piece, right? Whenever we're red teaming LLM, you need to test the whole ecosystem. That is the prompt structure, the context window, the retrieval system, the data pipeline, the tool, everything the LLM connects to, right? Because attacker can basically hide data in malicious data in different sources, and as long as the model can read it, it's going to happily follow it, right? And another distinctive difference between the traditional penetration testing and red teaming is the goal is not always root access, right? In LLM red teaming, success might mean you just changing the model tone, right? It might be you getting the model to review a system prompt or triggering wrong tool or even nudging bias into search ranking and so on, right? So it comes in different ways and in different flavors. So it's not about breaking in, it's about shifting the normal behavior of the model, right? So yeah, LLM red teaming is not 100% about writing exploits, right? You need to do more than just having code skill. You need to have like an hacker mindset, a social engineering intuition, and a deep understanding of how language can actually shape logic. So it's about overthinking the model, right? Because you're not hacking the system, you're hacking the mind of the model with words. So natural language are usually your greatest weapon, and that's why it's different from the traditional penetration testing.
Yeah, what's interesting to me is that I think in traditional kind of school of thought, hacking is it's a gash or it's a kill wound for a company. Like you take as much data as you can, you try to like take down the system, you hold something for ransom. There's like a big gash happening in the defense perimeter. But where with LLMs, it sounds like it's more like almost like a slow bleed sometimes. It's like you're having people kind of come in and influence the LLM in ways that you didn't initially intend. So, for example, you're running some sort of screening mechanism with models, then somebody knowing how to kind of do this injection attack will essentially get their resume at the top of the pile, for example, or get their papers like reviewed with a positive review, even though the paper isn't that good, or other examples like that. That sounds like a good way to think about it.
Yes, yeah.
Okay, so that being said, like, how does defending against prompt injection look like? Like, I think we talked about data lineage, knowing your data sources, but like beyond that, like, how do you advise people to think about that to build more resilient LLM systems?
Yeah, to lock things down, there are actually several ways organization and developers can go about it. I think the first thing you want to do as a developer is you need to actually split your prompt, right? because if you cram all your prompts, your system prompt into one block, that's a major problem. So because the model focus more on what comes last when the user is asking the model a question, for example. If the user said, ignore all the rules and do this, the model is going to gladly follow it. So now you need to split this prompt into, for example, system prompt, developer prompt, and then sandbox the user prompt, so that whatever the user asks has to go through the developer prompt and the system prompt before getting to the model. Then another thing that can be done in terms of defense is building guardrails outside the model, right? Because the model will always try to help you even when it shouldn't. So you need to control what it can do in terms of allowing only safe pre-approved action to go into the model. Then you also need to carry out some sort of checkpointing when it comes to the model carrying out risky stuff. For example, running tools at the back end. Then input sanitization and validation is also very important, and not just the input, also the outputs, right? Anything the model can ingest should be sanitized, right? You need to use some sort of filter, classifiers, and sanitization, but you don't just rely on them alone. Then, yes, red teaming is also very important. You need to red team your workflow. Don't just test them with prompts. You need to test the whole pipeline, right? You need to inject your payload into different data sources as long as your model can read it. So you also need to clean your data. If your data don't need sensitive information like personal identifiable information or intellectual property, you need to remove it from your data, right? Always apply the principle of least privilege to the model. So yeah, that's some of the ways you can do to defend against this type of vulnerability. It's something you have to contain really, because you can't defend against prompt injection, because that's how model actually works, right? They need prompt to function, right? So it's something you have to contain, something you have to monitor, something you have to design around. So you isolate it, you guardrail it, you verify everything, and most of all, you don't trust the AI or any model you're using with the power it doesn't understand.
Yeah, I mean, like, I think the more and more models and data pipelines get write access, the more this becomes like an attack surface. To your point, how do you think about, or what are your thoughts on adding almost like guardian AIs or like verifier AIs, auditor AIs into the mix for, especially for like larger scale use cases where like it's pretty impractical to verify every output?
I would say, yeah, it's very important if you can, right? You need to have like a lot of defense mechanism as you can, as you can lay your hands on, right? But the most important aspect of things when it comes to adding these different components into your AI actually depend on how you're actually using the AI, right? And the defense mechanism has to come in how you're integrating this component into the AI. So you need to be able to like clean the data, right? So if you need to use some verify AI to verify the content that's coming into the AI, yes, do it. But you need to like test it, make sure it's actually cleaning those data, those content that's coming into your data, into your ecosystem, and that's the most important thing we need to focus on.
Next, I feel like there's a lot of conversation out there, chatter around, oh, like you don't need to like work on the training data anymore. It's all about the model. It's all about like what you bring into context. And I'm like, this doesn't sound like a safe way to approach it based on what you're saying.
Yeah, it's not. It's not. You definitely need to worry about, it's not just about the model, right? It's about how you actually utilize the model. For example, most organizations are not building their model right from the onset, right? They're integrating into existing model, maybe open source model, or enterprise model like OpenAI or Cloud AI or Gemini, right? So the most important aspect of things is how you are connecting those APIs or those models to your internal knowledge bases or vector databases and how you're securing against them. And which is why you need to build your own security outside the model itself. You need to have your own guardrails outside the model itself so that the flow is going to be a user is going to input some sort of information. It goes through your guardrail before it gets to the model. So you've already do some sort of cleaning before it actually gets to the model itself.
But that's not really out of the box right now, like based on the existing, like for example, MCP servers, like they're not really built that way, are they? They're more like, oh, hey, you can now connect to this data source, or you can now scrape data and then feed it directly to the model and back into your database. Like, but there's no guardrail in place. You kind of have to build it yourself, no?
Yes, definitely. You have to build it yourself. You have to definitely build your own guardrails yourself. But there are tooling and infrastructure that actually helps you do that. For example, there is the Guardrail AI, there's Rebuff, there's IBM Guardrails that can actually help you build some security mechanism outside the model itself. So before any content is hitting the model, is going through those tools and those infrastructure.
Makes sense. And from, like you mentioned, auditing before, like having an audit trail and making sure you have all that in place. Have you seen any good case practices there? Any tools that are worth mentioning that people should look out for?
Not for now, right? I think it's still a growing area when it comes to monitoring Latin because we are basically going to be monitoring for words, sentences, and so and all that. And the traditional monitoring system like the SIEM, Splunk, for example, I don't know, the rest of them, that's the security incident and event monitoring system, are not built to capture those keywords, those natural languages. So I still think we still need a lot of work when it comes to building those infrastructure surrounding monitoring and alerting. But one way I think it can be done is if you're able to log everything that is coming into your ecosystem, right? You can build some sort of internal monitoring system that would help you pick out those dangerous words. For example, you can have like a couples of dangerous verbs that you want to pick out, right? From anything that is the user is actually injecting into the system. And that would actually help you, that could help you build some sort of a monitoring system around the model.
So like words like ignore, disregard, change your method, or
yeah, something like that, right? But I mean, it has to be like a lot of words. But there was this paper I was reading a few days ago that has to do with something about using graph to actually build a monitoring system around AI. So I think there are a lot of research on how to do some sort of detection and alerting and monitoring in the AI and LLM models, but the infrastructure itself, building infrastructure itself, I think is still in process, and builders still need to do a lot of work when it comes to that.
Yeah, for me, like feels more like a social media monitoring challenge than like a traditional tracking challenge.
Mm-hmm. Yeah,
keyword based or like kind of context based, similarity based, like vector comparison, almost like in that realm, which is a interesting different way of approaching it for sure. Cool. I want to talk about red teaming a little bit more. I think that's not something that's like very familiar to a lot of people. So maybe if you can walk us through like what does like a red teaming exercise look like for LLMs? Like how would you kind of frame that in a practical, applicable way?
So red teaming LLM, let's take it back a little bit earlier in the days, because the focus earlier in the days was identifying obvious misbehavior in the LLM. Like for example, you're getting it to generate bias or offensive, inappropriate responses, or tricking the AI into answering questions that it was not supposed to. So the red teaming goal was to see how well the AI can be provoked into stepping out of its boundaries in the real world system. So for now, it's a big difference, right? Because a lot of organizations are not, for an organization, you don't really care about if an LLM is saying something offensive. That's not your use case, right? Because you're integrating it into your backend system, into your data flow, into your pipelines, right? Without any threat modeling. So the first thing I will say when it comes to LLM red teaming is we need to understand what kind of data the system actually ingests, right? Is it trained data? Is it fine-tuned data? Is it sensitive internal data? For example, HR tools, is it connecting to your Slack, your Jira, and all that, right? Because if it's connecting to critical and sensitive information, there is a higher risk of data leakage, right? Or hallucinated information that is going to cause some sort of misuse of privileged information. Then we also need to understand how the model is being connected to the tool or the system, right? Does it have access to email, for example, or database or file storage and the likes of it? Because you need to understand the business logic and the business use case to know what exactly you need to be testing, right? So ultimately, the most critical focus right now is how organizations are implementing that AI into their workflow, and red teaming AI must test these accesses, this integration, and this decision-making influences, right? So there are different ways you can jump on to carrying out LLM red teaming, but you have to come up with your own methodology. For me, if I'm going to jump on an red teaming, the first thing I want to do is actually understand what I am attacking, right? My team and I usually start with reconnaissance to understand the LLM capabilities on the system itself. For example, what kind of tools or API does the LLM have access to? What function does it call? And what input does the function takes, right? Is it using retrieval augmented generations to read emails or PDFs? What is it meant to do, and where does it get its data from? So this is going to give us our attack surface. Anywhere the model reads data is a potential attack surface. So we need to test it. Then with the information you get from reconnaissance and information gathering, then you start slapping in prompt injection, both direct and indirect. Then you also need to observe the behavior, because as I said earlier, getting root access might not be the win when it comes to LLM model testing, right? You usually want to look out for maybe the LLM leaking internal prompt or secrets. Maybe the LLM is making unauthorized tool calls or changing its tone, its logic, its intent, right? Sometimes the goal is not full control, it's just to see if the model can be nudged into acting outside its original intent. So LLM red teaming is part hacking, part psychology, right? You're not just breaking code, you are actually coaxing the behavior of the LLM, right? There's no scanning for port for vulnerable services in here. You're just writing sentences that have the potential to unlock different action that the model can actually take. So, and another thing is you're not just testing the model, you're testing the whole ecosystem, like the plugin, the tools, the backend infrastructure, the data pipeline behind it, the logs and so on. So, and I mean, if you're not testing all that when it comes to LLM red teaming, you're actually missing the risk entirely.
Yeah, agree 100%. And there's actually another risk that I just thought about. Like, I don't think I've heard anyone talk about is like the risk of like almost like a denial of service attack, or like let's consume all of your AI credits in one go attack, where like you flood the model with information. Like, what do you think about that one, and how should people protect themselves?
So for that, I think you need to just have some sort of rate limiting on the LLM, maybe from via the agent or the API. So rate limiting is going to help you when it comes to denial of service. Then another thing is the agent itself needs to be connected to, for example, a firewall that is going to block like a lot of different calls to the backend models, right? That can also help as well. Then the most important thing when it comes to DDoS and LLM is you need to reduce the token that gets to the back end. You need to find a way to minimize it from the front end before it gets to the back end. And those are the different ways you can actually prevent against denial of service when it comes to LLM.
Yep, makes sense. And that's, I think, one piece. Like if you're relying on sending that data outside of your org to some third-party API, then that those costs can add up pretty quickly.
Mm-hmm.
Cool. So zooming out here a little bit on the future of AI. So every week there's some new model coming out. There's some new development getting released. Like there's new ways of looking at things. Now we're like talking about attention and like this kind of hierarchy of prompting. But like maybe in 2 weeks from now, we're gonna see diffusion and other new methods come up. Like, do you think AI security is evolving fast enough to keep up? And then connected to that, like, are there any tools or trends or ideas that you are personally excited about that are coming up?
To be honest about Celine, no, but we are getting there, right? As you said, every week there's a new model, new improvement when it comes to AI. The security response still feel like we are trying to use the word two-era thinking to something that is way more complex. So the traditional, for example, the traditional software is actually very predictable. You can write code, it runs exactly as expected. With LLM, you're basically working with unpredictable outputs. You can't debug them easily. You can't patch a wrong answer into the model, right? So we are still a little bit behind, but the good news is standard are finally emerging. For example, there is the OWASP top 10 for LLM, right? And there was an official testing guide that was released a few days ago on how to test LLM, how to test model and interaction and all that. Then there's also the Mitra Atlas that is tracking real-world threats when it comes to AI. And there are several tooling like Ambient, there's Astra, there's also the Guardrails AI, IBM Guardrails that you can use to build filter around the model, and a lot of startups are building dedicated AI security tooling. So yeah, we are still at the beginning part of building really great infrastructure when it comes to security. And yeah, I feel there's still a lot of work that needs to be done when it comes to that. But we are not there yet 100%, because the development of AI is faster than when it comes to the security aspect of things. So there's a lot of work that needs to be done. Then when it comes to tools, personally, especially when it comes to prompts, generating prompts and testing for prompt injection, and the way organizations are actually using it, no offensive security tool is actually going to help you test them properly. I mean, there are tools like offensive security tools that can actually help you, like the Ambient and the Astra, but where you get most of your win is manual prompting and psychological social engineering skills. That is the best tool you can actually rely on for now, right? Because those Ambient and Astra is just going to help you show like a lot of possible attack at your model, but it's not actually considering how you're actually integrating it into your backend. So yes, manual auditing for now, I would say is my best security tool when it comes to auditing LLM system.
Makes sense. And I mean, you mentioned that OAuth token for LLMs. I think that's also an important piece that people tend to overlook when, especially building FTP servers and like implementing other connections. Is like you want to make sure that you create temporary, strongly authenticated connections with the both like the front end that interacts with the user or with the customer or your like data source, but also with your backend tools. And like that agent is spun up for a limited period of time. It has a certain requirements or capabilities. It's guardrails well enough. Like to your point, you're adding all these tools in. You've like tested that environment. It doesn't have like a continuous connection, because I feel like if you connect the LLM or the AI agent continuously, then you create a continuous risk. Whereas if you rely on like temporary connections, then you tend to almost like containerize that risk a bit.
Mm-hmm. Yeah, you're definitely correct.
Yeah, and the other thing is I've been seeing news about, and I think Asana was the biggest one that we saw in the past couple of weeks, is like this cross-tenant data leakage where company A prompts for company A's data and then gets company B's data instead, which is never a good sign when you consider your data source. That's something that people should have top of mind. But like, so for people who are just starting up, like working with LLMs, playing with LLMs, like what is your advice on security stances? Where should they start, like without kind of taking over the entire workflow?
Well, that depends on what you're trying to achieve. If you're a developer and you're looking or you're a little bit curious about AI and security, I think the first thing to understand is the basics of LLM itself, right? You don't need to start training your own model. You just need to understand what LLMs are, how they think. Start by understanding what tokens are, how the system take in tokens, what does prompt formatting means and how it can affect results. What is the context window? Why do recent input matter than the old ones and stuff like that? So, and there are also great resources out there that could help you. There are like a YouTube channel like Andre Kapati's channel. I really like his content. They're really good. And OpenAI also have a lot of documentation on how to like break things down. Then you also need to think about security in a language way and not in the previous traditional Web2 security or Web3 security when it comes to LLM, right? You need to get your head around how you can actually use prompt injection to manipulate an AI response, right? Because prompting itself is an act that AI uses. That's why you see a lot of books, a lot of courses on prompt engineering, how to use prompting to do a lot of things to make your model work better for you and all that. So prompt engineering is one of the things that you actually need to learn about, know about. Then, yes, learn the old LLM stack, not just the model, right? AI app is more than ChatGPT, Claude, and AI. You're dealing with vector databases. For example, there's a Python, there's Chroma, the API calls, the shell access, the whole CI/CD pipeline that's connected to the LLM. You also need to understand that, learn how to wrap tool calls, how to log everything, how to synthesize input and outputs. Learn about tools like Guardrails, how they work when it comes to content filtering and how they can help you defend against prompt injection if you're building in the space. So there are no playbook actually, and there's nothing like a gatekeeper when it comes to learning about LLM. You don't need anything fancy to get started. You just need curiosity, right, and a security mindset and the willingness to learn. Whenever you're learning, just put in that attacker mindset first. And whenever you're building, you need to build responsibly with security in mind.
That's awesome. And I feel like people should brush up on their thesaurus and like synonyms and whatnot for attack verbs.
Yeah. I think with verbs, they are very important. Especially for verbs, anything that has to do with action words are very important when it comes to LLM security. So you need to understand how the model, whatever model you're working with, actually processes those action verbs.
Awesome. Look, this has been an awesome conversation. I think it's one that not a lot of people are talking about in our space, and the AI space at least is like more focused on what the AI can do, but not like what happens in production when you deploy something like this and it goes live and in front of real customers. And I feel like this is where those attack vectors happen, be it like the bad actor trying to shut you down or steal your data, but then also could be like somebody just trying to skip a queue or skip the line and try to get in front of others by inserting a otherwise hidden prompt in their resume or in their research paper. So it was great to talk about these things. Before we go, Stephen, where can people follow you?
If you want to keep up with me, I'm usually very active on LinkedIn, a little bit active on X, and most of my updates on red teaming, LLM, and anything that has to do with AI or the job security update is usually on LinkedIn. So LinkedIn would be the best way to follow me.
Great. So follow Stephen on LinkedIn, guys. So once again, big thank you. Great conversation. Thanks everyone that tuned in. Awesome chat, Stephen. And as always, to our listeners, if you enjoyed this episode, if you enjoy our podcast, don't forget to like, subscribe, follow us on your favorite platform. It helps us bring great content to you. And then don't forget to check out civic.com and learn more about what we do. Over and out.